Alright, so we're wanting to maximize z equals x sub 1 plus 3x sub 2 given these constraints using the simplex method. So the first thing we need to do, we need to set up our equations to put in the table. So remember, we need to introduce our slack variables to our inequalities. So that gives us that x sub 1 plus x sub 2 plus some value greater than or equal to 0. S sub 1 gives us 10. Yep. Oh. Good. Thank you. Gotta get glasses. Good. All right. So here are our equations, and remember that we're wanting to maximize z, but we need all of our constants on the right-hand side. So I'm going to move all of my variables to the left with z. So I'll end up with negative x sub 1 minus 3x sub 2 plus z equals 0. And now I have all of my equations, and we can start our table. So, listing out all my variables, x sub 1, x sub 2, so for my x sub 1s, I'm going to have 1, 5, 1, negative 1. X sub 2, I'll have 1, 2, 2, and negative 3. S sub 1 is only in the first equation, so I'll have 1 and then zeros down. S sub 2 only appears in the second equation, so I'll have 0 and then 1 in the second row. And then likewise for S sub 3, it's only in the third. And then z only appears in the last. And then my constants. All right. So we have our table set up, and now we need to find our pivot. So looking in the bottom row, finding the smallest negative value. So I have negative 3. So I'm looking at this column, and I need to find my pivot point. So I'm going to take each constant and divide it by the value in the row. So 10 over 1 is 10. 20 over 2 is 10. And 36 over 2 is 18. And so we come up at this point that I have two values that are equal to each other. They're both 10. Remember, we're looking for the smallest value, and I have a tie here. So we kind of need to make some good judgment decisions over here. Remember, our pivot, I need to force it to be 1. So I have two options I can choose from, either 1 or 2. This one's already 1, so I'm just going to pick 1 to be my pivot. All right, sounds good? All right, so now using our pivot, this one's already 1, so I don't have to force it to be 1 by dividing by the reciprocal or multiplying by the reciprocal or anything like that. So now I'm going to use the 1 to force everything else in that column to be 0. So to force row 2 to be 0, what should I do? Negative 2, right? So I'm going to do it different. Negative 2, row 1, and add that to row 2. And then likewise for row 3, I'll do negative 2, row 1, and add that to row 3. And then for the last row, I can do positive 3 times row 1 plus row 4. All right, so my top row is not going to change. So I'll still have 1, 1, 1, 0, 0, 0, and 10. Now my second row, I'm multiplying the top row by negative 2 and adding it to row 2. So this becomes negative 2 plus 5, which gives me 3. Negative 2 plus 2, which gives me 0. Negative 2 plus 0, which gives me negative 2. Negative 2 times 0 plus 1, which gives me 1. And then I'll have 0 and 0. And negative 2 times 10 is negative 20. So again, I get 0. For row 3, essentially the same thing, multiplying row 1 by negative 2 and adding it to row 3. So negative 2 plus 1 gives me negative 1. Negative 2 plus 2 gives me 0. Negative 2 times 1 plus 0 gives me negative 2. Then I'll end up with 0. Negative 2 times 0 plus 1 gives me 1. I'll have 0. And negative 20 plus 36 gives me 16. And then finally, my last row, multiplying row 1 times 3 and adding it to row 4. So 3 plus negative 1 gives me 2. 3 plus negative 3 gives me 0. 3 plus 0 gives me 3. 0 plus 0 gives me 0. 0 plus 0 gives me 0. 0 plus 1 gives me 1. And 30 plus 0 gives me 30. So check my arithmetic. We're good? All right. So remember that our goal is, if at all possible, to force all of the numbers in the bottom row to be positive. And we've done that. So we're done. We actually have a maximum value for z. And remember that my maximum value is right here. I know that z must be 30. And now we want to figure out, okay, what x1 value, what x of 2, what s1, s2, s3 is going to allow me to have this maximum value for z. So writing down, starting with my very last equation, I have 2x sub 1 plus 3s sub 1 plus z is equal to 30. And we were solving for z, so I'm going to move my x sub 1 and s sub 1 back to the right-hand side. So I get z equals negative 2x sub 1 minus 3s sub 1 equals 30. How about plus 30? Plus 30. And again, we want z to be a maximum value. I know x sub 1 and s sub 1 must be positive. And so if I allow them to be anything other than 0, it will decrease my value of z. So x sub 1 and s sub 1 just must be 0. So I have x sub 1 is equal to 0, and s sub 1 is equal to 0. And that'll be true every time we find a maximum of the other variables in the last row. All right, so whatever's down there, we automatically know is 0. And so now we'll use those values, work our way back up through the table to figure out what the other variables are. So remember, this is x1, x sub 2, s sub 1, s sub 2, s sub 3, and z. So I have x sub 1 and s sub 1. I know those are 0, so we can simply solve this third row to figure out what s sub 3 is. So I have negative x sub 1 minus 2s sub 1 plus s sub 3 is equal to 16. And we already know that x sub 1 and s sub 1 are 0. So I end up with just s sub 3 is equal to 16. And again, working my way back up into the second row, I have that 3x sub 1 minus 2s sub 1 plus s sub 2 is equal to 0. We already found that x sub 1 and s sub 1 are 0. So those 0 out and leaves me just with s sub 2 equaling 0. And so now looking at the very top row that you can't see anymore. Looking at the very top row, the last thing I need to solve for is x sub 2. And the top equation tells me that x sub 1 plus x sub 2 plus s sub 1 is equal to 10. And again, we already know that x sub 1 and s sub 1 are 0. So that just leaves me with x sub 2 equaling to 10. So my final answer, I know that the max for z is 30. And this occurs when x sub 1 is 0, x sub 2 is 10. And then for my slack variables, I know S sub 1 is 0, S sub 2 is 0, and S sub 3 is 16. So that is my maximum and the values that allow it to occur.